Hello again, my fellow pilots and aircraft maintenance personnel. Your host is always Haytham Aly, and I'm an aviation technical instructor. Welcome to my aviation nuggets for today. Today, you will join me in a quiz to recall basic engine thrust reverser system operation. We will have a quiz having like 20 MCQ question, multiple choice question, to recall the basic engine thrust reverser system operation. Okay, so let's start the quiz right now. Haytham Aly. And this is a basic engine thrust reverser system operation. Okay. So, question 1 of 20. To stop the aircraft within runway length available, the aircraft has to stop the aircraft within runway length available, the aircraft has aircraft wheel brakes, engine thrust reverser system, wing spoilers, all the above. So, the right answer is all the above. Yes, in the aircraft we do have aircraft wheel brakes, engine thrust reverser system, and wing spoiler. This is spoiler to spoil the lift on the wing, like the brakes for the wing. Aircraft wheel brakes. In most of the modern airliner, we do have normal brake and alternate brake. At least 2 hydraulic system will supply aircraft brake. Carbon multi-disc brake are the most popular one. And also we have engine thrust reverser system. We reverse engine thrust to stop the aircraft within a good distance. Okay, so most of the thrust reverser system operation nowadays, we reverse the fan stream, the bypass airflow, or the secondary airflow. Okay, and thrust reverser system operation must be done only on ground. So on modern airliner now, we have at least 3 lines of defense to operate the thrust reverser only on ground. We have at least 3 lines of defense to operate the thrust reverser system only on ground. This line of defense, first line of defense and second line of defense, must be a engine computer. But the third line of defense must be a system computer or an independent line of defense. So for example, in the Airbus A320, Airbus choose the SEC or spoiler elevator computer to allow the operation of thrust reverser system on ground. We have inputs, 3 inputs. We have locks on the thrust reverser cowl to deploy or to allow the thrust reverser system to operate. Okay, everybody, so let's proceed. Next question. Next one, question 2 of 20. Thrust reverser types, they can be either hot stream deflectors, fan streamed deflectors, or a combination of both. Again, this is a statement. Is it true or false? Thrust reverser types, they can be either hot stream deflectors, fan streamed deflectors, or a combination of both. This statement is true. This statement is true. Like the figure you see now, this is a clamshell thrust reverse, which reverses a hot stream, Also, we have bucket doors, and also we do have, or we may have, fan stream reverse translating sleeve or blocker doors. Fan stream translating sleeve or blocker doors. So in some engine, we may deflect the hot stream. Other, we may deflect fan stream only. Other engines, we may deflect both hot stream or fan stream. But in the modern airliner and on the modern engine, we popularly have fan stream deflectors, which are a translating sleeve or blocker doors to reverse the fan stream, to reverse the fan stream, to reverse the fan stream. Okay, everybody, let's proceed. Next question. Question 3 of 20. To slow the aircraft down without using too much braking, we use thrust reverser system. This statement is very true. This statement is very true. So, in the modern airliners, there is a thrust reverser system which reverses the fan stream or hot stream. It will play an important role besides aircraft brakes and spoilers. Aircraft brakes and spoilers. Okay, everybody, let's proceed. Next question. Cascade vanes that direct the gas flow in a forward direction. Yes, we do have cascade vanes to direct the gas flow in a forward direction. So this statement is very true, everybody. So what is the function of the cascade vanes? The cascade vanes, they have different angles and they direct the fan stream into the forward direction. And each cascade vane segment do have certain angle to deploy or to direct the fan stream forward, but must be away of important component of the aircraft, like away from the landing gear wires or landing gear components, away from the wing, away from the fuselage, from the cabin. So this cascade vane segment do have a certain angles, and in the maintenance, if you release this cascade segment, you must reinstall this cascade vanes segment in the correct position, because each one has a certain angle to deploy the fan stream or to direct the fan stream forward, but must be away from critical components of the aircraft. Critical components of the aircraft. Okay, everybody, let's proceed. Next question. I hope you enjoy these sets of questions to recall basic engine thrust reverser system operation. Basic engine thrust reverser system operation. Okay. Question 5 of 20. In theory, the more power that is supplied, the greater will be the reverser efficiency. Again, in theory, the more power that is applied, the greater will be the reverser efficiency. Yes, this statement is very true. First, I need to tell you that thrust reverser must be selected manually from the cockpit. And the pilot can operate the thrust reverser only when the throttle lever or thrust levers on the idle stop. So they can operate the thrust reverser levers or thrust reverser latching levers. Then they can put the throttle lever on a reverse idle. Okay. When the throttle lever at a reverse idle, the translating sleeve or blocker doors must be operated, and only when the translating sleeve or blocker doors are fully deployed, the pilot can take the throttle lever from a reverse idle to a maximum reverse. In that case, the power will be higher and the greater the efficiency of the reverser will be applied. But you need to remember that we cannot take the throttle lever from a reverse idle to a maximum reverse, otherwise the reverser translating sleeve or blocker doors are at fully deployed state. Okay, everybody? Next question. The clamshell doors deflect the gas flow forward from the engine exhaust pipe without using cascade vanes. This is an internal clamshell doors or external clamshell doors or all the above. I think this is an external clamshell doors. Because we do have two types of thrust reverser clamshell doors. An internal clamshell doors and an external clamshell doors. The internal clamshell doors always coming with a cascade vane to direct the hot stream in a certain angles or a certain direction. But the external clamshell doors, they deflect the gas flow forward from the engine exhaust pipe. But in the external clamshell doors, there is no cascade veins. There is no cascade veins. Okay, everybody, let's proceed. Next question. Next one, question 7 of 20. In the figure, what is used to reverse the hot stream? This is a bucket doors, internal clamshell doors, external clamshell doors. This one is a bucket doors. This one is a bucket doors. So the right answer is bucket doors. Okay, so bucket doors is very similar to the clamshell doors. Okay, and also in this case we deflect the hot stream. In the case of using a bucket doors, we deflect the hot stream. Okay, everybody, let's proceed. Next question. Question 8 of 20. On high bypass ratio engines where the fan produces nearly 80% of the engine thrust, these are used: cold or fan stream reverser or hot stream deflectors. I think on a high bypass ratio engine, always we reverse the fan or cold stream reverser. Translating sleeves and the blocker doors. Are being used. So when the translating sleeve go to the aft position, they deploy the blocker doors, and the blocker doors reverse the cold thrust or cold high bypass thrust. Okay, everybody, let's proceed. Next question. Question 9 of 20. The rearward flowing fan stream is directed in a forward direction via cascade vanes. The rearward flowing fan stream is directed in a forward direction via cascade vanes. This statement is true. Yes, we have cascade vanes. When the translating sleeve are going aft, they release the cascade vanes, and the cascade vane function is to direct the cold stream in a certain direction away from critical component of the aircraft. And take care always that if you release the cascade vane segments and reinstall it on the aircraft, you must put each segment in the correct position, because each position has a certain angle to direct the airflow with this angle only. Okay, everybody, let's proceed. Next question. Question 10 of 20. The main components of the fan cold stream reverser system: translating sleeve, blocker door, cascade vanes, all of the above. I think the right answer is all the above, because in a cold stream reverser system we have a translating sleeve, always operated by hydraulic system actuator. When they go to the aft position, they release the blocker doors to reverse the cold or fan stream using the cascade vanes in a certain direction away from critical components of the aircraft. Okay, so the function of the cascade vane is to direct the cold stream away from a critical component of the aircraft with a certain angles. Each cascade vane segments do have certain angles. Okay, everybody, let's proceed. Next question. I hope you enjoy these sets of questions to recall basic engine thrust reverser system operation. From figure, as the sleeve moves rearward, it pulls up the blocker door via the drag link and exposes the cascade vanes. Yes, as you can see here. Okay, in this schematic we do have translating sleeve, blocker doors, drag link, and cascade vanes. So this statement is true. Only when the translating sleeve going aft by hydraulic actuators, it pull the blocker doors via the drag link. And the blocker door will reverse the cold stream or fan stream, and the cascade vanes will be exposed to direct the cold thrust forward in a certain angles away from a critical components of the aircraft. Away from a critical components of the aircraft. Okay, everybody? Let's proceed for the next question. From the figure we see combined fan and hot stream reverser, only fan stream reverser, only hot stream reverser. In this one we see here cold reverse and hot reverse. So it is a combined fan and hot stream reverser. Combined fan and hot stream reverser. Yes, on some aircraft engine there is a design for a combination of fan and hot stream reverser system. There is a combination of a fan and hot stream reverser. Okay, everybody, let's proceed for the next question. Question 13 of 20. Angles of cascade vanes are important as they ensure high pressure air is directed away from major airframe components. Yes, this statement is very true. As you can see here, each cascade vane segment do have certain angle to direct the airflow forward away from a critical or major aircraft component. So this statement, everybody, is very true. This statement is very true. Okay, next one. The cascade vanes are very important for they ensure that high pressure air is directed away from undercarriage assemblies, flying controls, passenger cabin, all the mentioned above. I think the right answer is all the mentioned above. Yes, when the blocker door are released and redirect forward the fan stream, it is a very pressurized air. And this fan stream now go to the forward direction, not to the aft or exhaust direction. So the function of the cascade vane is to ensure that this high pressure air must go forward away from the critical component of the aircraft, away from an undercarriage assembly, away from the flying controls, and away from a passenger cabin to protect these critical components or critical part of the aircraft from this high pressure air coming from reversing the fan stream. Reversing the fan stream. Okay, everybody, let's proceed for the next question, and I hope you enjoy always Aviation Nuggets by Haytham Aly. Aviation Nuggets by Haytham Aly. Don't forget to subscribe to my YouTube channel, by the way. Okay, let's proceed for the next question. Normally, reverser cascade segments are removable for maintenance. Yes, as you can see here, this is the cascade vane segments. And normally, they are removed for maintenance. So the right answer is true. This statement is very true. So always take care, my fellow aircraft maintenance personnel. If you release or you remove these cascade vane segments, you must put each segment in the allocated location, in the right location. Okay, everybody? Next one, question 16 of 20. One important point is to ensure that each reverser cascade segment is returned to its correct position after maintenance. Yes, this statement is very true. This is why, because each cascade segment do have certain angles and direct the fan discharge airflow away from a critical component of the aircraft. So each cascade segment do have different angles. So each one must be returned back to the correct position. Each one must be returned back to the correct position. Okay, thank you so much. And let's proceed for the next question. They block the rearward flow of the fan air and direct it through the cascade vanes. Again, they block the rearward flow of the fan air and direct it through the cascade vanes. Is it the translating sleeve or blocker doors or thrust reverser actuators? I think the right answer is blocker doors. Blocker doors. Okay, so the blocker doors, when the translating sleeve are going aft or moving aft by hydraulic thrust reverser actuators, they move the blocker door through the drag link. And the blocker door job is to block the fan discharge airflow and expose now the translating sleeve moving aft will expose the cascade vane to have the fan stream forward in a certain angle, away from the critical component of the aircraft, like undercarriage components, like flight controls, like passenger cabin. Okay, everybody, let's proceed for the next question. Question 18 of 20. A method of thrust reversing, clamshell door, bucket door, cold stream reverser, translating sleeve, all the mentioned above. The right answer is all the mentioned above. All the mentioned above. Yes, all these three types are using to deflect either hot stream or fan stream. Hot stream or fan stream, or a combination of them. Okay. Next question, everybody. We come to an end now. Question 19 of 20. Question 19 of 20. They direct the air at a set angle. They direct the air at a set angle in a forward direction, so preventing damage to major structural components. Thrust reverser actuator, translating sleeves, or cascade vanes. The right answer is cascade vanes. Yes, the cascade vane job is to direct the air at a set angle away, in a forward direction, away from major structural components when exposed to the fan stream. Okay, everybody, let's proceed for the final question. I hope you enjoy these sets of questions. Question 20 of 20. Thrust reverser is only used as a means of slowing the aircraft once it is on ground. Yes, this statement is very true. And nowadays, aircraft engines do have at least 3 lines of defense to operate the thrust reverser on ground only. Okay, everybody, thank you for your good listening. And always fly safely and maintain your aircraft very safely. And please stay tuned for an upcoming session like this, hosted by Haytham Aly, your aviation technical training instructor. This is for my fellow pilots and my fellow aircraft maintenance personnel to recall aircraft systems. Thank you for your good listening, and I will meet you again. Bye-bye.